Hey gang, we are going to talk a lot about systems today. We've been working with exponential equations, and we are going to combine that with something that you guys have seen throughout the year, and that is the concept of a system of equations. And if you need a refresher, the purpose of a system of equations is to find the intersection point. And I have one here. We're going to go through a couple of examples. You are going to need your calculator out as we do this. If I started off with this system of equations, I have two equations. The first one is an exponential function, and the second one is a linear function. And I think maybe your gut reaction would be, oh, I see they're both y equals, so let's set them equal to each other and try to solve. Problem is, when we set them equal to each other, if you notice, I'm going to highlight this for you, you have an x down in your just normal base, and then on the other side of the equation, you have an x in the exponent. If you think, oh gosh, what do I do to solve this? You're probably in a boat as everybody else. This is actually not able to be solved by hand. When x is in the exponent on one side and x is in the base on the other side, it's not that you guys just don't know it. There literally is nothing that you can do to solve that by hand. But that does not mean that they don't intersect with each other. So what we are going to do is go to our calculators. I believe I showed this back to you guys when we first learned about our calculators earlier this year, but I'm going to review this with you. So if you are an 83 or an 84 person, you're going to hit y equals, and you are going to type both equations into your calculator. If you are an Inspire person, you need to type them in your calculator as well, but you go about it just a different way. Just make sure you guys have both equations and hit graph. Let's calculator graph this, and you will see it's kind of hard to tell, but this actually crosses two different times. So there's the one you can see my cursor up at the top that I think is the more obvious one. And remember, this is an exponential equation. So we have an asymptote that's right here along the x-axis. So if you follow my cursor, you can't see it because the pixels of the calculator program make it look like it just goes right onto the x or the y-axis, but it's not actually laying on the y-axis. There are points along there. So while there's one up here, you can see my cursor, there's another one down here. So there's actually two different intersections here. So we're going to have to find both of them. So if you have the same calculator that I do, you're going to hit second and then the trace button. You see on the top part, the blue calc. If you are an Inspire, just hit menu. I don't remember what it is on there then. Menu, and then I think you see it, maybe algebra. And then intersection, it says the word intersection. You might have to play around with that a little bit. I don't remember. We're going to go and either arrow down to 5 or hit 5. Now, the questions that pop up, you're going to think are silly. But that's the reason why you think it's silly is because you only have two equations entered in on your calculator. So you think, well, it's obvious those are the two equations that I want to find the intersection of. But if you think about, if you follow my cursor here, look at all these y equals that you have. Ideally, you can plug in, I think it's 10 different equations. The calculator is smart, but the calculator is programmed. And so it's programmed to automatically ask you these questions and ask you which curves you want to use. So whether or not you have 2 curves in here, or you have 10 curves in here, it's going to still go through and ask you which ones you want to use. Now, it starts the blinking cursor on the first one that you have listed. Is that an equation that we want to use? Yes, it is. So you're just going to hit enter. Then if you notice, it flipped the cursor over to the second one, which is the line, because it just goes in order down the list. So now here we are on the line, and if you see it blinking, it asks, is that the second curve you want to use? And you are going to say yes. I still don't know why, after all my years of teaching, why it asks you this guess. It doesn't matter. Just hit yes again, and it'll give you the intersection. Remember, my rule is to round to the third decimal place. So we're going to have 2.467 and then 0.067. Sorry, negative 2. So one of the answers is negative 2.467 and then 0.067. Now, if you are an Inspire person, you have the mouse pad in the middle of your calculator, and if you get that moving with your finger, what you just need to do when you hit the intersection is you need to just highlight over the intersection you want to use. So it's almost like you're creating a boundary in your graph where you say, this is in the area that I want to find my intersection. Once you have that highlighted, hit enter, and it should give you your answer. If you guys need help, Inspire people, since I don't have it on the computer to show you, you might want to grab a friend in class and see if the two of you can figure it out together. If not, I'll show you then tomorrow. So the next one, so that gives you the first one. What happens is it gives you the intersection point that it is closest to. So if I want to go up and find this second point now, I go second calc again. I'm going to go down to 5, and I'm going to arrow up to the right. It's going to follow, my cursor's going to follow along. And if I don't have to be right on top of it, if I just get really close to it and it's blinking near it, that's now where I'm going to start hitting enter. So here I am on my first curve again, hit enter. It bumps over to the second curve, hit enter. Don't worry about the guess, just hit enter again. And that one happens to fall right on the nice whole number 29. And so now we have our second point. So there's no math algebra steps that you have to include, but you still have to understand that you're finding an intersection point, and we're going to use our calculator to do so. So you're going to get to be experts with these of your calculators. So I'm going to do one more example so you can see how to do this. We'll go the one that I have here. It's a little bit more complicated. If you think about the first equation, this is an exponential. It has an x up in the exponent, so that's how I know it's an exponential. And if you think about it, this is a squared. That makes it a parabola. So I'm going to go back into my calculator. I'm going to move this over this way so I can see. I have y equals, I just clear my two equations from last time out. I'm going to put parentheses around these things as I enter them so that my calculator knows them the way that I want them in there. So I have parentheses 1/2 to the power of parentheses x minus 2 and then plus 1 at the end. And then I have the quadratic, which is x minus 5 squared minus 6. And I hit graph. Let's see how many times they intersect. So there's the exponential and there's the parabola. And you can see it intersects twice again. They're a little bit more obvious this time. So we're going to find the first one I'm going to find is on the left-hand side. So I'm going to go second calc, number 5. Ooh, my cursor landed a little bit over to the left, so just kind of get it close to the intersection I want. Hit enter for the first curve, enter for the second curve, enter through the guess, and I have the intersection. I'm going to round to 3 decimal places. So I'm going to have 2.194, 2.194, and 1.874, 1.874. So that's my first intersection. And let's go back again. To find the second one, I have to hit second, calculate again, down to number 5, and arrow over closer to the other intersection point. Yes to the first curve, yes to the parabola, yes through the guess, And there's my second. A lot of times, guys, because you're intersecting an exponential with a parabola or exponential and a linear, they're not going to be nice numbers most of the time. So I have what? 7.65, because the 5 is going to round the 9 go, so we're going to have 7.650, 7.650, and 1.02, 1.02. So that is how you're going to do this. That's all. When you have an exponential and another graph, you're going to have to just do it with your calculator, which I think you guys will like. There's not much work to it. So I suggest if you kind of couldn't follow along with your calculator as I was doing this, go back and hit pause. That's the nice thing about these videos. You can hit pause to make sure that you have it on your calculator. You saw what I was doing. If you look over here, these are all the buttons I was pushing. If you need to follow along with those, and it shows you how I entered things in. But it's always great to hit pause, go back, and go back to the video, different places where you need. All right, I will see you guys tomorrow.